Have you ever experienced a build process that mysteriously fails, sometimes running fine and other times crashing or timing out without a clear reason? It is a common and frustrating scenario, and a primary reason for these elusive build failures is insufficient central processing unit resources. When your build environment does not have enough CPU power, critical steps in your continuous integration and continuous delivery pipeline can grind to a halt. During a software build, your system performs a series of intensive operations. This includes compiling source code, running extensive test suites, linking various libraries, and packaging the final application. Each of these phases is a CPU-hungry activity. If the allocated central processing unit capacity is too low, these processes become starved, leading to slow performance, timeouts, and ultimately failed builds. Think of it like trying to run a marathon on an empty stomach. Your body simply lacks the necessary energy to complete the task. Modern build systems often leverage parallel processing, meaning they try to do multiple things at once. If your CPU cannot handle this concurrency, it becomes a bottleneck, causing processes to contend for limited resources and leading to instability. To tackle this, the first step is to actively monitor your CPU usage during build execution. Most continuous integration and continuous delivery platforms offer dashboards or logs that display resource consumption. You can also use system-level tools like HTOP on Linux or Task Manager on Windows for local checks. Once you identify that CPU is the bottleneck, you will need to adjust the resource limits for your build agents or containers. For example, in Docker or Kubernetes, you can explicitly set CPU requests and limits to ensure your builds have dedicated processing power. Additionally, profiling your build steps can pinpoint exactly which part of the process is consuming the most CPU, allowing for targeted optimization. An interesting insider detail is the concept of the noisy neighbor effect, especially prevalent in shared cloud environments. This is when another process or virtual machine on the same physical host hogs central processing unit resources, inadvertently starving your build process. Understanding this helps you advocate for dedicated resources or more robust resource isolation. Another powerful technique is implementing build caching, which significantly reduces CPU demand by reusing results from previous build steps, rather than recomputing them every single time. It is also important to consider the distinction between CPU cores and threads. While more threads can help with parallelism, true performance often comes from having more physical or virtual CPU cores available. By understanding the central role CPU plays in your build pipeline, you can move beyond frustrating, intermittent failures. Proactive monitoring and smart resource allocation not only prevent build errors but also dramatically reduce build times, improving your continuous integration and continuous delivery efficiency, and speeding up your software delivery cycle. It transforms your pipeline from a source of frustration into a streamlined, reliable engine for development.